Hi everyone, in this video we are going to discuss about the reflection of a point on a line which is parallel to the x-axis, and let's say the equation of the line is y equals a, and a is the distance, the lowercase a is the distance between x-axis and the line, right? That's the perpendicular distance between x-axis and the line. So suppose we have a point P which is at location x comma y, and we have to find the location of its image if we take the reflection on this line which is y equals a. The light green color line here which has an equation y equals a, and if we take a reflection of our original point P on this line, then wherever the image is going to form, we have to find the coordinates of that point, which is the P prime. In this diagram I have noted it as P prime in green, and let's assume this green dot is the image of our original point P when you take a reflection on the y equals a straight line. Now because we are talking about image, we have to assume that this line, the y equals a, that straight line, is now going to behave like a mirror. Let's assume that it's a mirror, right? It's a plane mirror, and on that mirror we are taking a reflection of the point P, and let's assume that the image is forming at P prime. So in that case, from the principle of reflection of light, we know that the distance of the object from the mirror will be equal to the distance of the image from the mirror. So in this case, what is the distance of the object? Well, the distance of the object is actually AP. So can we write it like this? So we can say, okay, then AP, this distance. So we are talking about pure distance, right? We are simply talking about distance. We are not considering positive, negative sign or anything like that. We are just talking about this distance. AP will be equal to AP prime, because A is a point on the mirror. In this case, this line is the mirror. So A is a point on the mirror. So from the mirror to the object, which is AP, that distance will be equal to the distance between the mirror and the image, which is P prime, right? Now let's try to find out what are the coordinates of A. If you think about it, the x coordinate of A would be what? The x coordinate of A would be same as the x coordinate of point P, because if you see, from the origin we have to go the same number of units on the positive x-axis or along the x-axis to come to the point A, right? So the x coordinate of A will coincide with the x coordinate of P. So I'm going to write here as x. So that is the x coordinate of A. And then what would be the y coordinate of A? Well, y coordinate of A will be the lowercase a, because from the x-axis we have to go only a units to reach the point A, right? So here the y coordinate would be a lowercase a, that is the y coordinate. So we have found the x coordinate and the y coordinate of the point A. Now if you think about the line segment P and P prime, A is actually the midpoint, right? Because AP is equal to AP prime, and it's a straight line, or rather straight line segment, and A is in the middle because it's bisecting the line, it's dividing the line segment into two equal parts, right? So A definitely is the midpoint. Now because we have a line segment and a midpoint, we can use the midpoint formula to establish the relationship between x and x sub 1 and all of this, right? So let me first write down the midpoint formula here. The midpoint formula, as we know, says that the x coordinate of the midpoint will be equal to the sum of the x coordinates of the extremes, the two extremes. So let me first write it as like x sub 1 and x sub 2 whole divided by 2. That would be the x coordinate of the midpoint. And similarly, the y coordinate of the midpoint is also like y sub 1 plus y sub 2 whole divided by 2. I have already created a separate video on the midpoint formula. Feel free to watch that video. I'll provide the link in the description of that video. So here, what is x? X is actually the x coordinate of the midpoint. And what is y? Y is the y coordinate of the midpoint. So what is x here? X is the x coordinate of the midpoint, and what is y? Y is the y coordinate of the midpoint. So if you simply look at this formula right here, the x and the y in this formula, they are slightly different. They are not the x and y that we have assumed as the location of our point P. So in this formula, the x and y, they are some generic variables we are using, that we are saying that, hey, if x and y are the coordinates of the midpoint, then their value would be like this, where x sub 1 and x sub 2 are the x coordinates of the two extreme points, in this case P and P prime. Similarly, y sub 1 and y sub 2, they are the y coordinates of the two extreme points. Again, the extreme points are P and P prime, right? P is the original point, P prime is the image. So from the x coordinate formula, can we write it like this? So I'm going to now say, x is equal to, so the x is actually the x coordinate of the midpoint, and coincidentally in this case the x coordinate of the midpoint is also x. Let me denote it right here. So you see the x coordinate right here, x coordinate of A is actually x. So I'm keeping that as x. So that is the x coordinate of our midpoint in this diagram, which will be equal to the sum of those 2 points x coordinates, right? So let's keep x sub 1 as the x coordinate of P prime, because that's what ultimately we have to calculate. And then for x sub 2, I'm going to use the x coordinate of our original point P, which is again x, right? You see the x coordinate of our original point is also x. So that's what I'm using there. And then the other extreme point, which is P prime, for that I'm using x sub 1. And then we have to divide by 2. So this is our original midpoint formula. And this x right here is nothing but this x right here, the x right here, this x is actually this x. It is the x coordinate of the midpoint, right? And then similarly, we'll also talk about the y coordinate of the midpoint. But in this case, this x is actually the x coordinate of the midpoint, which is equal to the sum of the x coordinates of the two extreme points, which is again the x sub 1, that is one of them, and this other x right here. So x sub 1 and x, those are the two x coordinates of the extreme points, and that divided by 2. So if we solve this equation, so we got a nice equation here, and if we solve it, what we get? Well, if we multiply both sides by 2, we get 2 times x on the left hand side. That will be equal to x sub 1 plus x. So from here we can say that x sub 1 is equal to 2x minus x, which will be x sub 1 equals x. So we have calculated the value of x sub 1. So that was one piece of it, and we also have to calculate the value of y sub 1, and we are going to take the similar approach. Now for the y sub 1, can we write it like this? From the formula we say, okay, the y coordinate of our midpoint. So the y coordinate of our midpoint is actually a. Now I'm going to let me write it in red color. So y coordinate of the midpoint is a. That will be equal to the sum of the y coordinates of the extremes. So one extreme would be y sub 1, that's the y coordinate of P prime, and then the y coordinate of the other extreme point, which is actually just y. You see right there, that's just y. That's the y coordinate of the point P. So I'm going to write it here as just y, and then whole divided by 2. And from here, if we solve it, what do we get? We get 2 times a is equal to y sub 1 plus y, and then from there we can say, okay, then y sub 1 is definitely equal to 2 times a minus y, which can be written as negative y plus 2 times a. And that's the second piece that we needed to figure out, and we have already figured it out. So the value of y sub 1 is equal to negative y plus 2 times a. And again, the way we derived these values using the midpoint formula, you really do not have to worry about the quadrant and the sign of the coordinates. You don't have to worry about that. We just simply need to use the x coordinate of the original point as the x coordinate of its image. However, the y coordinate of the image is going to be like this. It will be the negative of the y coordinate of original point plus 2 times of a, whatever is that value of a, whether a is positive or negative, whatever value it is, you are going to use the same value with the appropriate sign in here, right? So now we have the original point. So let me first write it down here. The original point had the coordinates x, y, and then its image that formed when we took a reflection on the y equals a line, its image is P prime, and its location or coordinates would be x. It is this x right here, the x right here that we just derived. So that x, this negative y plus 2a. So this is the general formula to remember that when we take the reflection of a point on a line whose equation is y equals a, then the location of the image would be x, negative y plus 2 times a. So let's take a couple of examples. Let's say we have been given an example. Suppose our original point, we have been given a point whose location is say 5, 10, and then we are taking the reflection, on a line which is y equals 2. So let's assume that the image location is P prime. So if we simply assume that image is at P prime, so what would be the coordinates of the image? Well, the x coordinate of the image will be same as the x coordinate of the original point. So I'm simply going to write 5 right here. This is that same 5, the same 5 that that we have as the x coordinate of the original point. So the x coordinate of the image has been calculated already. Now what about the y coordinate of the image? Well, the y coordinate would be negative y, meaning whatever is the y coordinate of the original point, I have to take a negative value of that. So negative y, meaning negative 10 plus 2 times whatever is the a in the equation of the straight line. So 2 times a, in this case a is actually positive 2 right here, a is the positive 2. So I am going to write 2 times 2, and this is the coordinate of the image. And if we simplify it, this is going to look like p prime. So our p prime will have the coordinates as 5 comma, so it would be negative 10 plus 2 times 2, that is 4, so that would be negative 6. So the coordinates of the image would be positive 5 comma negative 6. Let's take another example. Suppose we are taking another example where our original point is at, let's say, negative 5 comma negative 10, and also we have the straight line whose equation is, let's say, y equals negative 2. And we are going to take reflection of this point on this line, and we are going to find the coordinates of the image. So let's assume that the image is p prime. So suppose if the image is p prime, then what would be the x coordinate of p prime? Well, the x coordinate of the image will be exactly same as the x coordinate of the original point. So this negative 5, exactly negative 5, I am going to write here this negative 5. So that's the x coordinate. And how about the y coordinate? Well, y coordinate would be negative of the y coordinate of original point. So it would be negative of the y coordinate of the original point plus 2 times a. A is what? Right here, whatever is the equation, y equals negative 2, that is the a. So that would be 2 times of this, right? If you can picture it like this. So what we did, we used the same x coordinate as the original point. However, for the y coordinate, we are taking the opposite sign. So it would be negative of whatever was the y coordinate of original point plus 2 times a, and this is the a equivalent right here, right? So this is our a, meaning when we took the equation y equals a in our general derivation, we used y equals a, and in this case a is actually negative 2, as you can see there, right? So that is why I am using negative 2 right here. So that's the negative 2, which is the value of a, and then this is the negative of y, meaning our original y was negative 10, and here for the image we have to use negative of that, right? So from here, if we simplify a little bit, our image is going to be like this, meaning the coordinates of the image would be negative 5 comma, and then this becomes positive 10 and then minus 4, so that would be 6. So the coordinates of the image would be negative 5 comma 6. I hope everything made sense. Thank you for watching. See you in the next video.